In inverse variation, an increase in one variable results in a corresponding decrease in the other variable it is related to. A good example is when you consider the amount of money that you have spent and what is remaining in your pocket. The more you spend, the less that remains in the pocket. So you realize that when we are having questions or when we have a problem involving inverse variation, the word inverse is likely to be seen somewhere in the question. And also worth noting is the fact that these two variables in inverse variation behave like a reciprocal of one another. So we have this example. A quantity x varies inversely as y. There's a typing error here, sorry. So a quantity x varies inversely as y, and that x is 1/9 when y is 27. Find x when y is 1/30. So we start coming up with a mathematical equation using the first statement here. A quantity x varies inversely as y. We shall write that as x varies. We use that variation sign. Inversely means you write 1 over this quantity here. So 1 over y. Now the next thing is to change this to an equal sign. So we shall have x is equal to, the moment you change this to an equal sign, you must introduce a reciprocal, a constant in this side. So we shall have to use, let's use k as our constant. So that one is equal to k times 1 over y. So if you do this, you realize k times 1 gives us k. So we can write this as x being equal to k over y. K times 1 is k, so we can write this as x is equal to k over y. Having done that, then we come and make use of this. X is 1/9 when y is 27. So we shall substitute them. We shall say when x is 1/9 and y is 27, we shall substitute x with 1/9 and the y, this y with 27. So the equation will be 1/9 is equal to k, that's what we are looking for, over y. Y is 27. Then the next thing now is to cross multiply, because we want to get k. For us to get k, we cross multiply. If we cross multiply, we realize that we shall have 9 times k giving us 9k is equal to 1 times 27. So 9k is equal to 27. We want k, so we divide both sides by 9. And when we do that, you will get your k being equal to 3, because this cancels here 3 times. So that means we can write the complete equation, this one in complete form, as x is equal to 3, because we have found the value of k to be 3 over y. That's the complete equation. Now we use it to do the second part of it. Find x when y is 1/30. So we shall say when y is 1/30, x will be equal to y, this 3 here on the numerator side, over y. Instead of y, we replace it with 1/30. Recall that you cannot easily divide by a fraction, so the only thing we do here is to change this to a multiplication as we write the reciprocal of this. So we shall have x being equal to 3 times 30 over 1, and that gives us 90. So that means the value of x is 90. The value of x is 90. So that's how we work out that question. The next one, another example, we are told a quantity p varies inversely as q. Given that p is 0.4 when q is 25, we are to determine the value of q when p is 0.1. So we start by coming up with the equation. We shall say p varies inversely means we write the reciprocal of this, so 1 over q. The next thing is to come up with an equal sign here, and we introduce a constant of proportionality, so that will be p is equal to k times 1 over q, which you can simplify to p being equal to k over q, because k times 1 gives us k. So it's like for us to, when we are dealing with an inverse relationship, it's like we write one quantity here is equal to a constant over the other quantity. That's the approach we shall use in the next example. Now back to our question. We have got the incomplete equation which relates p and q. We have been told that p is 0.4 when q is 25. So we shall say when p is 0.4 and q is 25, we substitute them here. We shall have to substitute 0.4 here. So we shall have 0.4 is equal to k. K is the constant we are looking for, over 25, the one we have been told here. Now, how do we get k from this point? We multiply both sides by 25. If we do that, you realize that this gives us 1. So, and this cancel. So we shall have k being equal to 1. I've cancelled this and this. So if we remain with k being equal to this. And when you simplify it, you get 1. So that means we can write the complete equation, or we can write this one in complete form by replacing k with 1, because that's the value of k we have found. So that will be p is equal to 1 over q. That is the equation connecting p and q. Sometimes some questions may ask you to find the equation or the relation connecting p and q. So that is the equation we have talked about. Now, second part of the question is to determine the value of q when p is 0.01. So we shall say when p is 0.01, then q will be equal to, we substitute this 0.01 where we see p, which is on this left side of the equal sign. So we have written it here, is equal to 1 over q. We are looking for q. Now, let's multiply both sides by q. We shall have this q and this one cancel. So we shall have 0.01 q being equal to 1. And for us to get q, divide both sides by the coefficient of q, which is 0.01. And when you do that, you get q is equal to 100. Now, third example, a quantity y varies inversely as the cube root of x. Given that y is 0.02 when x is 1000, determine the value of y when x is 125. So as usual, we shall start writing the relationship between, or finding the relationship between y and x. We shall write y varies as, because it's inversely, we shall have 1 over. So y varies as 1 over x. Not x, but the cube root of x. We have written 1 over because this is an inverse relationship. And then we are told it varies inversely as the cube root of x. So we have to look for the cube root of x on the denominator side. Change this to an equal sign. We have to introduce a constant here. So we shall have y being equal to k over cube root of x. Remember when we were dealing with this, when we were working this previous question, I mentioned that it's like when we are changing this proportion sign to an equal sign, it's like we say p is equal to the constant over the other variable, because it's an inverse relationship. And I promised you that we were to use this logic down here. That's what we have used. So I've said y is equal to the constant over the other variable to which it is related, which is the cube root of x. Now, having done that, then we use this part here, this one. We are told y is 0.02 when x is 1000. So when y is 0.02 and x is 1000, then we shall substitute these ones here to help us get k. So we shall have 0.02 here is equal to k over cube root of 1000. Because our x is 1000, but we have this value is supposed to be cube root of x, which is 1000. And then that is equal to 0.2 being equal to k over 10, because the cube root of 1000 is 10. Multiply both sides by 10. you will get this giving you 0.2 being equal to k, because this and this cancels. So that means we can write the complete equation, this one in a complete form, as y being equal to 0.2 over cube root of x, because we have found the value of k to be 0.2, like that. Now we use it to determine the value of y when x is 1.125. So we shall say when x is 125, y will be equal to 0.2 over cube root of x, which is 125. So that is to say cube root of 125. We know the cube root of 125 is 5, so we can write this as y being equal to 0.2 over 5. If you simplify this, you will get y being equal to 0.04. That is the answer. So that's how we work out these questions.